Good morning, everyone. This is Tom Marciano, president of the New York State Wireless Association. And I just want to let everyone know that we're going to wait another 30 to 60 seconds before we get rolling here. And we've got a great panelist today. So just sit tight, please. Thank you.
Okay, everyone. We're going to get started. All right, this is Rob Ivanoff. I'm the president of the New Jersey Wireless Association. Thank you, Tom. Just want to say welcome. Thanks, everyone, for taking time out of their busy schedule to attend our second webinar. And we've got a great speaker on a topic that I know is of high interest to everyone. And now I want to introduce Lucia from who's on the New York Wireless Association board, and she's going to do an introduction for Ken, and then we will get right into the program. Take it away, Lucia.
Thanks, Rob. Good morning, everyone. Lucia Chiocchio. I'm on the executive board of NYSWA. I'm also vice president of the organization, serving under the leadership of Tom Marciano as president. We're really pleased to have everyone participating in today's webinar. We've been happy to coordinate with New Jersey Wireless Association on this webinar series. A few things before we get started. Some notes before we start. So please ask all questions via the Zoom control panel on the bottom of your screen. So we'll have some Q&A at the end of Ken's presentation. The presentation slides will be emailed to all registered attendees. And if you'd like more information on today's topic, please feel free to visit the websites for NYSWA and the New Jersey Wireless Association, which are both on your screen. Before we begin, on behalf of both organizations, I'd like to thank our sponsors of this webinar series. Without our sponsors, we would not, neither organization would be able to do what we do and organize and present on these important topics. And here are New Jersey Wireless Association Gold sponsors. And their silver sponsors and bronze sponsors. So once again, thank you for supporting us as we present on these topics in a whole new forum and in a whole new way due to the current conditions. So when the two organizations were starting to brainstorm about what the topic would be for our next webinar, we quickly decided that 5G and the concerns about health effects about 5G was the next topic, the next timely topic to discuss. And the reason is we're seeing the demand for broadband and wireless services grow exponentially. And that was true before COVID-19. Now during this pandemic crisis, we're seeing the demand just increase even more, if you can believe that. But thinking about people working from home, online classes, telemedicine, it's just critical to have wireless services to be able to get through your day. RF Emission Safety has come up because of this demand. We're seeing a growth in the infrastructure. The wireless carriers and the tower developers and And the small cell developers need to build the infrastructure to meet the demand. And that infrastructure build is causing a lot of folks to talk about RF emissions and safety. It's a complicated topic. There's a lot of misinformation out in the public domain about it. So we're very pleased to have Ken with us today to talk about it, talk about some of the basics, and clear up some of the confusion. So our presenter today is Professor Kenneth Foster. He's the Professor Emeritus of Bioengineering at the University of Pennsylvania. Ken has been working since 1971 on the biological effects and medical applications of electromagnetic fields. He's published more than 170 papers on the topic. And I have to say, anytime I ask Ken a question about something, he immediately emails me a very well done paper that he's written on it. So he's clearly an expert on the topic. He's a long-term member of the committee that sets exposure limits for RF. He's a registered professional engineer in Pennsylvania, and for 20 years has consulted on assessing RF transmitters with FCC exposure limits compliance. So with that, I will turn it over to Ken, and thank you, Ken.
Oh, thank you. Okay, share screen. How's that?
Perfect.
Great. By the way, I want to thank you for putting that photograph of me. It must be 10 years old. It reminds me of my youth. But anyhow, if you can see my picture now on this webcam, that's a more realistic picture of me and my dotage with a haircut that's probably 6 months out of date. Anyhow, again, just as a point of clarification, I have been a consultant to wireless industry for years, assessing compliance of transmitting facilities with SCC limits. And also some of my research in the past few years has been supported by the Microwave and Wireless Forum, mostly involving exposure assessment related to 5G and millimeter waves. I guess as a matter of background, I was told that most of the audience comes from the wireless industry and they know exactly what we're talking about. But just to start off, what do the G's mean? Well, as the wireless cell telephone industry has developed, it has gone through a series of generations of different technologies. The first 1G technology consisted of phones about the size of something that you could fit in the trunk of your car, which used basically repurposed television bands. Then a few years later, more mobile handsets became introduced. The industry moved to digital transmission as opposed to just analog transmission to allow better voice communication, support more customers, and also, and by between 2G and 3G, the phone system was starting to transmit data. 4G, which was just developed a few years ago, allows much more data by changing the technology, and 5G is going to continue this. And so engineers, and I guess the wireless industry, as well as government, just views 5G as a sequence and a progression of the development of wireless telephone industry. I don't see it on my, I don't see the right-hand side of my slide now, but the general tendency is that as the Gs developed, as different generations of cell phone technology were introduced, the cell phones became more efficient at transmitting data. On the left-hand slide, I showed the radio frequency spectrum. The earlier versions of cell phone technology, like 1G and 2G, use frequencies around 1 gigahertz, 500 megahertz to maybe 2 gigahertz. And as time has gone on, the tendency has been to use higher frequencies because this allows more data, faster data transmission, more bandwidth available. However, at higher frequencies, as we approach the millimeter wave band from 300 gigahertz to 30 to 300 gigahertz, the energy propagates less far is more absorbed by building materials and scattered by vegetation and so forth. So at lower frequencies, you have easier propagation, but lower capacity for transmitting data. At higher frequencies, particularly the millimeter wave range, you can transmit much more data, but the propagation environment is more complex. I apologize for the spelling mistake. I just noticed it right now. And of course, 5G is just the current new big thing. I've already started to see advertisements and papers about 6G, which will even increase the speed of data. You have to ask, why is this developing? Well, it turns out that initially cell phones were mostly used to transmit voice data. I remember my first cell phone, I almost counted every word I spoke because it was just very expensive. And as time has gone on, these devices have become more capable of transmitting data. The content we transmitted was much more data intensive, and the cost of cell phones came down. So the people started using data much more so than the past. At present, nearly all of the traffic on cell phone networks around the world consists of data. Almost everybody's grandmother is on Facebook using their smartphone, et cetera, et cetera. Kids are walking around watching TV shows and videos as they walk around the streets and hopefully not get hit by cars. So we're looking at now a exponential growth in the amount of data carried by cell phone networks. This came from an Ericsson mobility report. I think it's a global data traffic. And to give you some sense of the numbers here, the scale is in exabytes, and according to Wikipedia, 1 exabyte is 100,000 times the content of print material in the Library of Congress. So we're talking about basically 100 exabytes per month. 5G is just the latest development that's going to help companies support this tremendous increase in the amount of data. It's just now coming online. For years in the future, I expect that most data will still be carried by traditional 4G networks, but as time goes on, 5G will continue to increase its load. The advantages of 5G are not just allowing faster data transmission, but it provides what's called shorter latency. There's less delay in passing signals through the base station. It's designed to allow many more devices to be connected to a network through the cell phone system. And so the futuristic predictions are that in our Internet of Things, we're going to have sensors in our bodies, and our refrigerators are going to have sensors, and everything's going to be connected to the cell phone system through 5G. 5G allows many more devices to be connected to a network. But we're also going to see very important applications based upon cell phone technology. I noticed on the internet yesterday, the Vodafone is talking about supplying 5G navigation and control to ferries in Europe. And I'm hearing stories that in the future, brain surgery and heart surgery may be controlled by 5G. Hopefully not in my case, but sometime in the future, we'll see these very interesting and important applications allowed by the very efficient transmission of data in 5G. Very efficient and very fast transmission of data in real time. So 5G, I hear the public talk a lot about this. I attend community hearings sometimes, and I read a lot of stuff on the internet. I'm also receiving a lot of information and questions from the public. And the public seems to think that 5G is some unique kind of physical agent, but it really refers to a set of engineering standards that let cell phones communicate. So it's not anything distinctive in itself. It's, you think of, this is just a set of rules that allow phones to operate, which provide the possibility of faster data transfer and shorter latency and so forth. The term doesn't refer to cell phones operating in any specific frequency band. Actually, 5G now is defined to operate in 3 separate bands. The so-called low band is basically the same as present cell phone bands. And in the United States, the carriers that have implemented low band 5G are mostly repurposing existing cell phone bands. There's a mid band, which is being used around the world. It's somewhat higher frequency than used by current cell phone systems, but not much. And then high band is the thing that's causing the most public concern, which uses frequencies 25 gigahertz or above, which approach the millimeter wave band, which start at 30 gigahertz. And this has not really been used so much in public-facing applications, but has been widely used for point-to-point data links. I guess a lot of cell phone base stations are linked together by millimeter wave point-to-point data systems. But it's a high band that seems to be causing a lot of discussion. So when the public protests against 5G, they seem to be protesting against the use of millimeter wave technology for communications. But 5G seems to be the label for that describes the concerns. 5G also incorporates numerous technical innovations. The most important from the point of view of public perception is that 5G systems are going to heavily use so-called small cells. These are antennas that are mounted on tops of ordinary telephone poles or low towers running down people's streets. And so this is a new part of the technological environment, which is apparently triggering some concerns. These are very low power cells, but nevertheless, these are new in the environment. 5G also uses so-called MIMO antennas, multiple input, multiple output antennas, which mean basically that the cell and base station has in it the possibility of transmitting simultaneously in each direction as many as 8 or 16 or more individual beams, which will be individually steerable. And so a person who may conceivably have their own beam providing data to them directly. So 2 people may be sitting on a park bench, one using a smartphone connected to a 5G network getting a signal, the next person reading a newspaper, and their signal level at where they sit may be much lower than the person using the phone. And so here we're talking about a much more complicated kind of transmission involving many different beams steered around in different directions towards individual users. The public is concerned about small cells, but in practice, the existing cell phone companies have been moving towards reliance on small cells simply to cover the rapid increase in data. The Small Cell Forum recently published this illustration showing the growth of small cells, and as of the present, there are thousands of small cells in the United States, most of which are for 3G or 4G LTE networks. Since 5G now is starting to roll out, we're seeing small cells that are either combined with 3G or 4G stations, or maybe standalone small cells for 5G. And these will increase in the future. But now, and maybe for the next few years, by far the largest number of small cells will be for existing cell phone networks. Again, simply to provide a way of covering the rapid increase in demand that cell phone companies are trying to deal with. Small cells are placed closer to subscribers, but they operate at much lower power levels than so-called macro cells that are placed typically on building rooftops. The essential technical demand of cell phone technology is to provide a signal to a user that is strong enough to be useful for the user, but not so strong that it will create interference to other users located in other adjoining cells. And so because of the essential nature of the technology, the signal strengths have to be somewhat limited, again, by the need to provide a useful signal for a individual subscriber, but also to prevent inefficiencies in the system. The small cells that are being installed now, my own carrier has just installed a bunch of small cells near where I live in Philadelphia, will typically transmit 10 watts or so. A macro base station located on a rooftop may have several transmitters which may transmit collectively a few hundred watts of power into the antennas and maybe a few thousand watts, so-called effective radiated power. So these operate at much higher power levels, again, to provide a signal of a useful strength to the service area. When cell phone technology was first introduced in the 90s, companies would install cell sites on top of 150-foot towers out in the countryside, and they would service an area of several miles across. Later, the companies would install somewhat lower power cell sites on top of rooftops to support a much smaller area, and now companies are installing small cells at the block level to support an even lower number of subscribers. And eventually, you'll see small cells or microcells installed in individual homes, which of course is already happening in commercial spaces. So this represents an incredible increase in the number of transmitters. It doesn't necessarily represent any increase in the amount of radio frequency signal that's available, again, because that's limited by the nature of the technology. The problem with 5G is that it's now much harder to assess exposure. For existing networks, you can just go to the internet, find the specifications for an antenna. Antennas would be mounted in a certain location and their beam would be fixed. And it would be very easy to determine where the signal goes and at any point in space what the signal will be. But if you have an array of antennas moving beams around space, following subscribers as they walk around using their cell phones, it becomes somewhat harder. And there are significant research efforts around the world, largely in Europe, to try to quantify exposure from these 5G antenna systems. This just came in today from a colleague of mine, Joseph from Ghent University, showing measurements he's doing around the small cell. I think it's Lille in France. Again, the need for wireless carriers need to ensure that their small cells, or in fact any of their base stations, satisfy safety limits. In the United States, those of the FCC. And again, with small cells with MIMO antenna arrays, it's not an extremely easy thing to do. In the industry, there's a concept called compliance boundary, which is the distance from an antenna where you can be absolutely certain that this radio frequency signals comply with safety limits. You can calculate this compliance boundary on using worst case assumptions, assuming that all the beams from this array are pointed in the same direction, for instance. And if you do that for a set of antennas, this I think is for a standard Ericsson air antenna array, you get, which would mount it in a macro cell. This shows a compliance distance of something like 13 meters, maybe 50 feet. Or you can do a realistic calculation to calculate average exposure over 30 minutes, which is how exposure limits are specified for the public by the FCC. And if you take into account the fact that beams are going to move around space and the average exposure over any reasonable length of time will be pretty low, well, then you get the compliance boundary shown in the orange line, which is maybe a factor of 3 smaller. For small cells operating at 10 watts, it's not such a big deal. The compliance boundary may be 3 or 4 feet or less. And as long as the carriers don't mount the small cells in crazy places, right next to someone's window, it's not a problem. They may need to do something to make sure that non-utility service people don't go right in front of the beam, but that's something that they can deal with. From a point of view of the FCC exposure limits, 5G is just another radio frequency signal. It doesn't create any special problems. It's just a signal comparable to 3G, 4G. The only complications are with MIMO systems where you're dealing with multiple antenna systems. But again, this is a matter of calculating the compliance boundary in an appropriate way. If you ask the public why they're concerned about 5G or listen to the activists, we get two kinds of concerns. One is what I would call a generic concern. The public has been frightened about radio frequency energy forever. I got into this field in 1971 when I got my Ph.D. in physics and joined the Navy doing medical research. And I was assigned to a lab studying health effects of radio waves. And at that point, the rhetoric was exactly the same as we're hearing now. The public would be concerned about the safety of military communication facilities and radar, and they would protest. The health agencies would sponsor research that generally didn't really show much, but there were some unexplained findings. Health agencies would have expert reviews and not really see any clear evidence of a problem other than just too much heating. And this has continued unabated since the 70s. Public anxiety, health agencies not really seeing a problem, lots of research, some of which was with clear interpretation. This is becoming, again, more of an issue for 5G because you have this new presence in the environment, namely many small cells running down people's streets, which are much more visible than antenna arrays on neighboring buildings. Despite the fact that the small cells that are present in the environment are mostly for 3G, 4G installations. There have been a number of surveys, mostly in Europe, but maybe a few in the United States, looking at the average exposure of an average person in the population to radio frequency energies. And invariably they show that the strongest source of exposure to an average person is when he or she uses his own cell phone. You're putting a small transmitter right against your head. The next highest exposure is when somebody in his or her environment uses a cell phone. So now you have a small transmitter a few meters from your body. And then after that, there are a whole bunch of other small sources, Wi-Fi, cordless phones, microwave ovens in the house. Some small fraction of the average exposure in average non-occupational settings is from cell base stations outside the building. And of course, in industrial settings, you have people working in very close proximity to very high power transmitters, and all bets are off. But for the average consumer, most exposure they get is when they use a cell phone or when somebody near them uses a cell phone. And exposures from base stations are generally pretty small. This, of course, varies all over the place. If you happen to walk outside and right in front of a base station, well, the signal may be stronger than otherwise, but roughly speaking, this is the case. Now, one of the concerns I often hear expressed is that all these small cells will increase my exposure to RF energy. Well, there have been some very good studies done in Europe to try to address that question. And the answer is it's not necessarily clear that that's the case. Companies install small cells mostly to carry additional load, data traffic, but also to provide better signal strength to the users. So if you're a user near a small cell, okay, you have a small signal from the small cell, but the signal makes the cell phone happier. And since cell phones operate under so-called adaptive power control, their output is determined by the signal from the base station, the cell phones transmit less power. And so as a generalization, if you install small cells, you provide better signal strength to the users, which allow them to their phones to operate at a lower power. This past year, I sponsored a high school student doing a science fair project who simply measured the number of bars in his cell phone compared to the transmitted power from his cell phone. And when he went to the basement, the phone was operating at full power. And when he went up to the upper story bedroom, the phone dialed down the power, and the number of bars went up. simply because the adaptive power control regulated the transmission of the cell phone. So with small cells around and a better signal, phones operate generally at lower power levels, although all of these signal strengths are so variable that you can find exceptions that disagree with it. The other set of concerns I hear about is whether the millimeter waves that some high band phones will operate at are somehow uniquely dangerous. The signal levels, the frequencies that are transmitted in low band and mid band are essentially the same as those of existing phone networks, plus or minus, and they wouldn't seem to raise any special health issues, which have not already been examined many times in the past. But here's a new frequency range that's being introduced. And so when the public worries about 5G, I think they're talking about their fear of health effects from millimeter waves. Now, this energy doesn't penetrate the skin. The energy penetration depth of millimeter wave radiation in the body is perhaps 0.2 of a millimeter, which is mostly absorbed in the dead outer layer of the skin. So we're not talking about any kind of deep exposure to the body. I've spent a lot of time in the past couple of years calculating absorption of millimeter waves in the body, and it doesn't really get in past the skin. That doesn't prove that there's no hazard, but it doesn't suggest that you should be particularly concerned either. This came from Dilbert this past weekend. I will let you read it, but basically Dilbert is asked, this reporter thinks that 5G is dangerous, what's your answer? And Dilbert says, well, maybe I should study it first. Well, it turns out that people have been studying this, both from an engineering perspective in determining the amount of exposure to 5G, but also there's an increasing and already large amount of science about possible health effects of millimeter waves. It's not necessarily clear in its implications, but there is science there. When I got into this field in 1971, I was looking at a few hundred studies in the literature on biological effects of radio waves. This has just continued to expand exponentially. If you look at the number of scientific studies of biological effects of radio waves, everything combined, you're now looking at a literature of more than 3,500 different papers. These are not all standard risk studies. They could range in effects of radio waves on snails to biochemical effects and so forth. But it's a large literature. The cell phone industry got going in the 90s, and because of concerns about brain cancer from cell phones and other health effects, starting in the late 90s, a lot of research was done looking at effects of communications type signals, cell phone signals on biological systems. Again, these are a mixture of standard risk studies as well as just a large number of random biological effect studies of all sorts. But there's also been an increasing number of studies of biological effects in millimeter waves. I think probably now there are 100 studies out there. Again, most of these are biological endpoints that don't have any clear relation to health. The exposure levels may be far higher than those allowed by exposure limits. The studies are typically very small. Many of them are not well done. And they make all sorts of claims. And so here we're now looking at this enormous literature. If you want to go through this and pick and choose studies, you could convince yourself that almost anything is possible, simply because of the very large and rather noisy nature of the literature. Almost everybody who does some kind of experiment using radio waves or millimeter waves finds some kind of effect. Whether the effect is due to heating of the sample or some kind of subtle artifact or some kind of real phenomenon is not so easy to determine, but there are many reports of some kinds of biological effects from radio waves over the whole spectrum. Now, to respond to public concerns, almost every year some health agency mounts a very extensive review of the literature, and there are now several hundred of these reviews going back to the 70s, and they uniformly conclude that there's no clear evidence of any kind of health problem, but there are all kinds of questions, and they all recommend more research. And I don't see any real change here, but there's a lot of research there. We know that millimeter waves are dangerous at high exposure levels. You can think of this as being something like infrared radiation, which is also absorbed in the skin. At high levels of exposure, you can produce skin burns, thermal pain, eye damage. The military has a non-lethal weapon called active denial, which beams very intense pulses of 94 gigahertz millimeter waves at people with the idea of producing temperature increases in the skin that are painful. As soon as the pulse ends, the heat dissipates into the body and the pain goes away. But this is sort of a microwave version of rubber bullets. And I was involved in some of the safety studies involving those. These have nothing to do with communication facilities, but they are hazards of millimeter waves. The FCC and other exposure limits are designed to protect against all known hazards of millimeter waves, which at present involve too much heating of the tissue. The activists say that the FCC's blinker doesn't consider any so-called non-thermal effects. I think a more realistic assessment is that the FCC is relying on health agencies which have looked at the literature and don't see any clear evidence of hazard at low exposure levels. They do see clear evidence of hazard from high exposures. So this again goes back to a controversy which has been going on for decades. So the public asks, are 5G signals safe? This is what Dilbert asked in that cartoon I showed you. Well, one thing we can say is that all transmitters of radio frequency signals must comply with FCC safety limits. And these limits are similar to those that are adopted in most countries around the world. Most countries have adopted a set of standards which we call ICNIRP, ICNIRP, International Commission on Non-Ionizing Radiation Protection, which are similar to those of FCC. FCC just this year updated, well, continued their present limits, which go back to 1996, based upon a statement by the Food and Drug Administration that they considered these limits to be adequate. Health agencies haven't established any health hazards from environmental exposures to RF fields, but of course they all recommend more research. The problem is that the number of standard risk studies done using millimeter waves is rather few. The US Air Force sponsored a long-term cancer study involving millimeter waves back in the early 2000s, which was negative. They sponsored some studies looking for thresholds for burns in humans or ocular damage, which involve high level of exposure. The problem is it's not so easy to decide what to do. If you put a rat in a millimeter wave field, well, all the energy is going to be absorbed in the fur. So doing standard risk studies is easy to call for, but it's not so obvious how to do it, and these are very expensive. But they need to be done. There have been only a few exposure surveys involving 5G. I showed you a slide from University of Ghent showing one such survey. But of course, since 5G hasn't really fully operational, you can't do a study so far on entire population exposure because there aren't that many 5G networks. So if we look at when I'm asked, is 5G safe, I invariably defer to health agencies. Otherwise, it just becomes a case of your expert versus my expert. And I found, I keep up with the literature on reports from health agencies. One, and they're consistent so far, one very insightful response I saw was by a member of the European Commission in response to a petition from some activists asking for a moratorium on 5G. This was now 3 years ago. And what he said was, we've had our best experts examine this. Health agencies that we trust have looked at this, and we are convinced that based upon present knowledge, these exposure limits are protected. However, to expand upon the answer I showed you, we will continue following this literature, and they are also funding research on this. And this is the European Commission's response. The FCC, I'm sorry, the FDA, Food and Drug Administration, late last year and early this year, said again that they consider the current limits on RF energy from the FCC are acceptable for protecting public health. We can be sure that health agencies will continue to follow this, maybe support more research, and if their views change, they will certainly make their views known to us, and the industry and the regulators can react accordingly. On the other side, there are some very articulate individuals who are making very strong claims. The one who's probably best known to the public is Martin Pall, who's a retired biochemist, I think from Oregon State University, who is going around making many statements in the public with, in my view, over-the-top statements. He says that 5G rollout is insane, and he's predicting that we will see a crash in the human reproduction almost to zero in the next few years. You can look up his thing on the website. His views have found no agreement by health agencies, but there's a large fraction of the public that is very sympathetic to this point of view. His YouTube video I linked to has got 107,000 views so far, which I would guess is probably 107,000 times more than any of my YouTube videos I've ever seen. So that's the other side. And there are some scientists who are arguing for so-called precautionary responses, not allowing 5G of any type to be installed until it's proven safe. This is a matter of judgment. I personally would tend to go along with the European Commission's point of view, saying that they are following the issue and will react accordingly, but I suppose one could take different positions on that. I mentioned before that there are some needs. Well, the compliance assessment is going to be a problem because these MIMO antennas send their beams all over the place. And the question is, do you want to base your compliance assessments on absolute worst case, which means quite large compliance distances, which are far more than necessary to protect against overexposure. The public views these compliance distances as being the boundary between safe and unsafe. And I could imagine that the industry will have legal problems if someone comes closer than a compliance distance to a 5G antenna because of that perception. I'm not a lawyer, but I can see this happening. The scientific evidence is a real mess. There need to be more systematic reviews by health agencies of the literature. Knowing what I do about the literature and the extreme mixed nature of it, I don't anticipate any earth-shaking changes in understanding will occur, but we need to have this examined by health agencies, and they need to follow the literature as it develops with the understanding that if they see clear evidence of a health problem, they need to be very forthright in describing them. This hasn't happened yet. Since 1971, in my experiences, the literature has been reviewed consistently with the finding that more research is needed, but we don't see a clear sign of any hazard. And I would be surprised if anything different came out in the future, but human nature is not perfect and we need to have health agencies examine this. It doesn't help to have people like Martin Pall cherry pick the literature and pick out little bits and pieces that support their very dire predictions of the health situation. The literature needs to be surveyed in a neutral and comprehensive way by health agencies to avoid cherry picking. And since I understand a lot of the audience here is from industry really needs to be careful with communicating risk to the public. Don't let your engineers make loose statements about risk or lack of risk to the public, because the public knows and radio frequency engineer may not necessarily be an expert on health, and that doesn't necessarily increase the amount of understanding and empathy with the public. I think that's probably the end, except I will just note that I'm now starting to see stories, perhaps still hype, that after 5G, well, 6G is coming, which is going to be even faster than 5G. So get ready, folks. I think we're going to be looking for a wild ride in the future. One thing I could suggest is I just completed a survey published in Health Physics earlier this year on aimed at supposedly a non-technical audience, although it may still be too technical for most people. And you can obtain this from the Health Physics Society, and it's available online without going through the paywall. And so if you want a somewhat more technical, but hopefully not too technical discussion of this, feel free to download this. Thank you. That's it.
Great. Thank you very much, Ken. That was very informative. I think we have a little bit of time for some Q&A. And Rob, I think you're muted, so.
Still on mute, Rob.
There you go.
Okay. Can you hear me now?
There you are.
All right. While Ken was talking, some great questions have come in, and want to get to those. And we're there we go. Okay. Reminder, please use the control panel on the bottom of your screen for Q&A. Just a note, today's presentation slides, Ken's presentation, the references, and we will have some other materials should be up on our website, both NYSWA.org and NewJerseyWireless.org within 24 hours. So we'll get those up as maybe sooner, as fast as we can. Ken, just wanted to, one thing that you ended with, and I want to emphasize, and since we both have a lot of gray hair and all of the 50 years worth of studies, and as you recall, the FCC just took another look at these safety standards in, I believe it was 2018, and still concluded that there's no scientific evidence with a definitive link between wireless device use and any illness, including cancer, COVID-19. Is that a fair statement?
I should point out first that since I started using a cell phone, my hair turned white and my stomach got big.
Okay.
So I believe that the quote you gave was directly from the FCC website. So that's correct. Now, FCC is not a health agency. They mostly rely on the Food and Drug Administration and I guess other health agencies, as well as standard setting bodies, to make their decisions. So they are reflecting accurately the understanding of the Food and Drug Administration.
And the research is ongoing, which is fantastic.
Yes.
Yeah. And just, you have seen, you referenced one individual that's, talking, I don't want to say, I guess, cherry picking studies with some ill health effects is one thing. You probably remember the cancer in rats study that went around a few years ago. Can you talk about those anecdotal type things that seem to get out of the media and ignore the large body of work that there is no established link with wireless and any type of illness?
Yeah, I'm not sure these anecdotal stories. The literature is extremely murky, very confused, and there are all sorts of reports of so-called effects of exposure, which may or may not be well established. It's just that people who want to make a case, as opposed to people who want to objectively review the literature, can pick and choose these studies and then give them the most dire possible interpretation and say that the world will come to an end. So to contrast this, health agencies who do careful reviews lay all the literature they can find together, have criteria for what studies they will pay attention to. If a study had poor dosimetry or lacked blinding or had some other fault, they would disregard it and then they would focus on studies that are technically well done, and they come to different conclusions. So I'm not sure the term anecdotal applies. It's just a question of interpreting different parts of the evidence. The rat study that you talked about was just completed a few years ago, and it actually reported an increase in cancer of some kinds in rats exposed for a lifetime at exposure levels. I think these are to GSM and CDMA around 900 megahertz, which were substantially above safety limits. And it's unclear exactly how to interpret the results. So once again, people who were convinced there's a problem latched on this as saying there absolutely is a problem. Health agencies are somewhat more guarded. The International Agency for Research on Cancer, which had a definitive review of the literature some years ago, still hasn't said that radiofrequency energy causes cancer. It says merely that it's a possible cause of cancer, indicating that there's some level of suspicion. So what we're dealing with is a large body of evidence which supports, even for health agencies, some level of suspicion, but not enough for them to conclude that there actually is a problem. And this situation has existed the entire time I've been in this field, and I don't see it changing. That's just the nature of human knowledge and the strong personal feelings that many people have about the topic.
Yeah, and that leads me to another point you made that I want to look at a little further and just talk about, and that is the power levels. As you noted, small cells have a lower power output than macro sites, and as you know, and we talked about this, you know, when you were doing your presentation, and I noticed a number of questions came in to talk about. There's much less power on a small cell than in a macro site, and actually by having these small cells closer, that the smartphones actually power up and down, and if the signal's closer to them, there's actually less power output or less RF energy put out by the smartphones the closer they are to, like, a example is a small cell as opposed to a macro cell. Can you?
Yeah, well, again, the nature of cell technology is that you need to provide a useful signal to a phone, but if the signal is too strong, you can cause interference to users in neighboring cells. So just because of the limitations of the technology, you're not talking about the possibility of very strong signals. Because of the so-called inverse square law, the signal strength where you are at any point depends upon how close you are to the nearby transmitter. And so in some locations, maybe the strongest signal may be from a small cell, and others may be from a macro cell on a roof. But all of these signal levels really have to be within some limits. But we're dealing with a highly variable quantity here. Generally speaking, having small cells providing a stronger signal would cause people's handsets to transmit at lower power because of adaptive power control. And there may be exceptions one way or another.
Okay. And that even, and all of the RF energy, RF emissions, whether it's from a smartphone or small cell or macro, are all within the limits, the FCC specified limits, which is what a lot of these studies are based on.
Well, yes. And if any provider overexposed anybody to RF signals above the limits, they would hear about it from the FCC. The penalties are pretty severe.
Okay. And just go back, it was at the beginning of your presentation, and I know a big area of confusion is the frequency bands that are used in 4G and then in 5G. Some of the some of the same frequency bands are being used. And then you also have what we call the new high band frequencies, the 28 gigahertz. Can you just clarify that, just so everybody understands that a lot of the 5G low, what we call low band, and when I started my wireless career, Ken, 30 megahertz was low band and 150 megahertz was high band. But so that's how things have evolved in my career. But talk about the 4G, 5G frequencies at low band and mid band, and then what we now call the new frequency, not really new frequencies, because the 28 gigahertz, as you noted, have been used on point-to-point and point-to-multipoint systems going back quite a few years.
Yeah, well, I mean, 5G is just enormously hungry for spectrum. And so there are many more bands that are being purchased. A lot of spectrum has been purchased by the carriers. Generally speaking, the low band systems that are used, say, by T-Mobile are repurposed from existing 3G and 4G. The mid-band frequencies are somewhat above those that are used by 4G, but not much. And I believe that some of them are now transmitting on repurposed 4G bands, although I don't have the numbers right in front of me. But we're talking about frequencies that are similar to those used by the higher end of 4G. And again, 4G systems operate over a whole range of frequencies too. Typically up to maybe 2,500 megahertz to 5G mid-band. Some systems operate at those frequencies, some go up to 3,500 gigahertz, megahertz, but it's in the same general ballpark. The high band signals are approaching the millimeter range, depending on the carrier. In the United States, it could be 28 gigahertz up to 39 gigahertz for AT&T. And this gets into the millimeter wave band, which has not been used for consumer-facing devices, but has been used for point-to-point data transmission, airport security systems, and so forth. That seems to be the thing that's causing public concern.
Okay.
I should point out also that there's not going to be too much rollout of millimeter wave technology in this country. I think Verizon's doing a bit, but it's too expensive. It's going to, the propagation difficulties are quite high. Signals just don't travel that far. So maybe you could see the stuff used in millimeter wave range, say outside of office buildings or in spectrum, in stadiums where you have a lot of subscribers and need a lot of data. But I think carriers now are putting most of their money in low band and mid band. It's cheaper and provides some of the benefits of 5G without the technical problems of millimeter waves.
Okay, we're coming up to the end of time. Lucia, did you see any Q&A come in that you want to?
Yeah, so one question, and this has come up a lot. The question was, is 5G millimeter wave ionizing or non-ionizing RF?
Radio waves are non-ionizing in the sense that the photons that carry it don't have enough energy to break apart molecules and form free radicals. Ionizing radiation is things like X-rays, ultraviolet radiation, which causes free radicals, and it's free radicals that are biologically so damaging. So radio waves, including millimeter waves, are definitely non-ionizing radiation. I should point out that many people have infrared heat lamps in their bathrooms. So they sit under an infrared lamp and they feel nice and warm, and that's at a higher frequency and more energy per photon than millimeter waves. We don't perceive heat lamps as being particularly dangerous. So there's a perception issue here, which somehow is different for millimeter waves than for higher energy infrared radiation. Also a form of non-ionizing radiation. But again, public perception of risk is sometimes difficult to understand.
Okay, thank you, Ken. And I just want to note to anybody that sent in the Q&A that we will have answers to all the questions on the Q&A and the chat, and we will be posting those up on our websites That may take another couple of days, but let us work through that. So please, we want to address all of your questions. And so we can wrap up. I want to thank the NYSWA sponsors. And I want to thank our New Jersey Wireless Association annual sponsors, our gold sponsors, our silver sponsors, and our bronze sponsors. And thank you for joining us. Just want to let you know that we already are working on our next webinar session, which I think is going to be of interest to the group also. As you are aware, in New Jersey and New York, there's some small cell legislation that has been introduced. And then actually in New Jersey, it's going to be going to a committee hearing. So we have on September 23rd, we're going to have a webinar to talk about this small cell legislation, also give you an update. Some of you may have seen that the US Ninth Circuit recently ruled on the broadband acceleration. The ruling was very favorable to the industry. So you're going to want to hear some details on that. We will have more details on that in the next couple of weeks. Also, Lucia, you wanted to mention something about your scholarship fund.
Yeah, so NYSWA is very happy to announce that they established a scholarship fund with SUNY Impact. And you can go to the NYSWA website for more details, but we're very excited about this new initiative for our organization. Thanks, Rob.
Okay, no problem. And next week, as a reminder, if you haven't signed up yet, our annual charity golf event, we're actually going to get together in person. As you probably know, one of the few things that are close to being normal is playing golf. So we're looking forward to that, September 1st, 10 a.m. at Forest Gate Country Club. We still have a few open slots, and the registration and details are on our website at newjerseywireless.org.
Well, thank you for inviting me.
Yeah, Ken, we'd love to have you. Let's work out the details.
And 5G does not cause coronavirus. Make that very clear.
Okay. Thanks, everyone.
Thanks, everyone.
Thanks.
Bye.